Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello guys, I'm Dhiraj and I welcome you all on the Testbook.com, and I'm here to provide the best I have. So guys, once again I came back with another brand new session of for Kamyab series, that is gate mechanical, right? And today we are going to discuss, just forget about this, my dear. Today we are going to discuss about the MSQs of power plant engineering, IC engine, thermodynamics plus RAC. Yes, my dear, yes or no? We are going to discuss about the MSQs right now. आज हम क्या डिस्कस करेंगे? दैट विल डिस्कस द MSQs, my dear. Okay, so बच्चा पार्टी, we are going to start the session at sharp 1. Okay, so I can see that still the people have not joined, so we'll wait for a few minutes so that the people will get joined, and then we'll begin the session, बच्चा पार्टी. Okay, so wait for a minute so that the people will get joined, and then we'll begin. Okay, so yes, so my dear, right now it's 1 sharp 1. So I want to let you know that if you are interested in SSC JEE mechanical live coaching, then my dear, you have to fill the application form, and the link of that application form has been provided in the description of this video. As well as, my dear, if you are interested for the gate mechanical, then the form is also provided for the gate mechanical, and if you have any kind of a query, feel free to call on that number. The number has been provided in the description box of this video. And one more thing that I want to tell you, if you are interested to give more mock test, like for gate examination or ESC or any other technical or non-technical examination, my dear, you can buy the textbook pass just for rupees 299, and you are getting 14 months of validity and plus 3 months Ghana plus subscription free of cost for it, right? So guys, you can also explore the mock test, which is available free of cost in the website as well as in the app of Testbook. Okay, so these are the various offers for you guys by the testbook.com. So get benefited of this opportunities and offers, my dear. Okay, so इसका जरूर फायदा उठाएं. So my dear, now we'll begin. अब हम लोग शुरू करेंगे. That we are going to begin with the MSQ session, right? So today's the first question will be on your screen, and my dear, this is the first question on your screen. You can check it out. ये पहला question है आज का. So my dear, you can just see. Just wait a minute. Okay. So just wait a minute, my dear. Okay. Give me a minute. Yes. So my dear, here you can see that they said that air at 20 degrees centigrade flows over a heating coil whose surface temperature is how much? 45 degrees centigrade. The temperature of the exit here from heating coil is 40 degrees centigrade. Okay, which of the following statement are going to be true? कौन सा statement true होगा? That we have to identify. Which statement is going to be true? That we have to find out, right? So my dear, for concluding this, what we have to do, we have to find out each and every term, right? So my dear, let me draw that coil. So here, yes, bacha party, just look at me. Okay, and supposed to be, this is my coil, my dear. We have drawn the same temperature, and it is what? T2, and supposed to be temperature of coil is T3, that is nothing but 45, right? Air at flows over a heating coil whose air, that is 20. Okay, and our exit, that is 40, right? So you know that bypass factor will be what, my dear? Bypass factor क्या होता है बच्चा पार्टी? It is nothing but T3 minus T2 divided by T3 minus T2 divided by what, my dear? T3 minus T1, right now. So here I can write, my dear, T3, that is going to be 45, T2 40 divided by what? T3 again 45, T1 20. That is what, my dear? 5 divided by how much? The 25. So it should be 1 upon 5, that is 0.2. So my dear, my efficiency is going to be, efficiency क्या हो जाएगा? 0.8. Efficiency is going to be nothing but 0.8. I hope you got it, that how I identify, because you know that efficiency is nothing but what, my dear? 1 minus BPF, that is bypass factor. So definitely it is going to be 1 minus 0.2, and we are getting 0.8. So bypass factor of the coil is going to be 0.2, that's correct. Efficiency of the heating coil is going to be 80%. That's correct, right? So option number 1 and 3 is going to be correct. So this is the first, what my dear, this is the first what? This is the first multiple select type of questions, right? So the same question will be appear in the GATE examination, right? आपको कैसे find out करना है, that I already told you. Now my dear, we'll go for the next one. Next पे चलते हैं. So next one is here. My dear, in a piston cylinder arrangement, initially 1 kg of air is stored at 100 kilopascal. P1 is given, T1 is given, right? The piston is massless. Massless means the mass of piston will be 0. Okay, that means we don't have to worry about the mass of the piston. And is in mechanical equilibrium. और वो किसमें है? Mechanical equilibrium में है. That means no imbalance force within the system, right? And heat is added to the system until the volume of air doubles. That means V2 is going to be what, my dear? Twice of V1. After the system undergoes the isothermal process, after the system goes under an isothermal, that means T temperature is going to remain same. That is T2 is equal to T1, right? Until the volume reaches its initial stage. Okay, that's great. Now, what they said? Which of the following statement is going to be correct? That we have to identify. So how we can identify? The same approach we can apply. Just we can, what we do, my dear? We definitely and definitely, first of all, let me tell you, that is going to be what, my dear? P1 V1 is going to be MRT1. So definitely my V1 is going to be what, my dear? MRT1 divided by P1. I will put the value and get the answer. मैं क्या करूँगा? I will put the value and get the answer. M is what? 1.287, 300, 100. So my dear, my V1 is going to be M1 R.287, T1 27, that is 300, divided by P1. P1 is what, my dear? 100. ये गुजर गया. What we are left with? We are left with only 0.287 into 3. That is what, my dear? 0.861 meter cube. कितना? बच्चा, but it is going to be 0.861 meter cube, and this is going to be your U V1. Now you got V1, my dear, right? Now what you will do? And the volume has been double, right? So definitely, my dear, temperature will also be that double. Yes or no? Since, see, V is directly proportional to T. So definitely, my dear, if your temperatures, when your volume is get double, definitely your temperature will also get double. So then, my dear, I can say T2 will be what? 600. Yes or no? Definitely. And my dear, V2 is nothing but twice V1. So I can get heat added. Heat added क्या हो जाएगा बच्चा? My heat added will be MCP delta T. That is what? T2 minus T1. So it is going to be, M is what? CP is going to be what, बच्चा party? CP is 1.005. 1.005, and it is going to be 600 minus 300, right? So it is going to be 301.5 kilojoule. It is what, my dear? Q. ये किसकी बात होगी? Q की बात होगी. Now we have calculated what, my dear? Q. Q तो हमने calculate कर लिया. Now listen to me. Now you have Q. So my dear, work done. Similarly, you can calculate work done as well. So my dear, what it should be? It should be PdV. It should be what, my dear? PdV, na? Right. So definitely your V2 will be before that, but you have to calculate V2. So V2 is going to be 2 into V1. V1 is what? 0.8861. So definitely this value will come around, बच्चा party. कितना आएगा ये value? 1.722. So my work done is going to be what, my dear? P into V2 minus V1. So you know that P is given 100. कितना दिया है बच्चा party? 100 kilopascal. So 1.722 minus V1. So definitely it is going to be कितना आएगा बच्चा? 0.861, that is 86.1 आ जाएगा ये. It is going to be what, my dear? 86.1 kilojoule, right? Yes or no? This is going to be your W. Now, my dear, you have W, you have Q. So what is the change in internal energy? Change in internal energy क्या होगा बच्चा? You have, so definitely, my dear, change in internal energy, that is delta U, is going to be Q minus W. Q is what? 301. First law of thermodynamics है ये. 86.1. So my dear, delta U is going to be how much? कितना आएगा 215.4. Okay, now listen to me very carefully. Now we have isothermal process, right? Isothermal is when the process is isothermal, that is when T is equal to C. So then my dear, dt is equal to 0. That means change in internal energy is going to be 0, right? V1, V2, that you know that will remain same, right? So you know that it should be what? ये क्या हो जाएगा बच्चा? W is going to be in isothermal process is going to be what, my dear? M Cp ln of V2 by V1. M Cp, right now क्या हो जाएगा? M Cp ln of T2 by T1. Yeah, we can say, or we can say, my dear, what? P1 V1. You can say यहाँ पे MRT1 की जगह पे you can say P1 V1 ln of V2 by V1. So P1 is 100, V1 is what, my dear? 0.861. Or P2 V2 you can say, or just you can say P2 V2, or you can say, my dear, or we can say, okay, we'll do one thing. एक काम करेंगे. Here we can get, my dear, listen to me. What I'll put in terms of P2 V2, and my dear, ln of what? V1 by V2. Okay, so I'll get W. So W क्या आएगा बच्चा? It is going to be 100 into 1.722 ln of 0.861 divided by 1.722. Right, my dear, what will get? W कितना आ जाएगा बच्चा पार्टी? Your W will be minus 119.36. Minus 119.36. What, my dear? Kilojoule. Right? Okay. So heat added will be what, my dear? Heat added will be क्या हो जाएगा? Because heat is nothing but delta U plus W. So ये तो zero है. So definitely Q is going to be minus 119.36. That means what? It is heat rejection. It is what? It is nothing but what? Heat rejection, na? It is negative. So definitely it is a heat rejection. So the change in internal energy will be what, my dear? Combining both process. अगर आप दोनों process को combine करते हैं, so definitely initially we got how much change in internal energy? That was 21.54. So definitely change in internal energy on combining so it is going to be 215.4 kilojoule, right? What else remains? Now they have net work done. Net work done कितना मिला हमें? Let me check. So net work done will be what, my dear? पहले तो हमें positive मिला. We got positive, that is how much? 86.1 minus 119.36. So my dear, how much you got it? कितना मिल गया आपको? That you get minus 33.26 kilojoule, and this is going to be your answer. I hope you got it. I hope you got it, my dear. Yes or no? This is a required answer, right? So now we'll check it out. अब हम check करेंगे कि which one is going to be correct. So see, the total internal change during the whole process is going to be 215.4. It's correct option. Net work done by gas during whole process 33. No. Heat added during isothermal process is 119. It's what, my dear? ये क्या हो जाएगा? It is going to be incorrect because minus 119 है, right ना? तो heat has been rejected, right? So ये नहीं होगा. So heat added to the double the volume of air is 3.1.5. Let me check. Yes, 3.1.5, correct. So definitely 1 and 4 is going to be correct option. आपके ऑप्शन क्या हो गया करेक्ट बच्चा? आपके ऑप्शन हो गया करेक्ट. ओके बच्चा पार्टी विल गो फॉर द नेक्स्ट वन. अब एक नेक्स्ट पे चलेंगे. विल सी द नेक्स्ट न्यूमेरिकल नाउ. सी हियर, ध्यान से देखें. A 10 stage axial flow compressor. How many stages it have? 10 stages. Okay. Provide an overall pressure ratio 5 with an overall isentropic efficiency 87%. Overall isentropic efficiency is how much? 87%. The temperature of air at inlet is 15 degrees centigrade. Work is equally divided between all stages with 50% degree of reaction. Degree of reaction is 50%. Okay. The blade speed is, that is U is equal to 210 meter per second. The axial velocity, that is VF, 170 meter per second. The blade angle at inlet 41.65. Blade angle at exit will be this. और क्या होगा, that we have to identify, हमें find out करना पड़ेगा. Okay, so we can easily find it out, right? हम इसको easily find out कर लेंगे. कैसे? I'll tell you my dear. You know that U is equal to क्या होता है? U is equal to, we have solved I think this numerical already, we have solved, right? U is equal to क्या होता है बच्चा? VF tan of theta plus tan of phi. And theta and phi is nothing but what, my dear? Blade angle at inlet and outlet respectively. So U is given 210, VF is given 170, is going to be what, my dear? Tan theta plus tan of phi. My dear, I'll get tan of theta plus tan of phi is going to be equal with, किसके बराबर आएगा? 1.235. 1.235, right? So now, my dear, I'll get T2 by T1, and let me draw the velocity, diagram, so that you have a better idea of isentropic efficiency that I already explained you while teaching, that is T and S. Okay. Right, in this way you can draw it, right, my dear? Now now we can write, now my dear, I can write easily, that is T2 by T1 is going to be P2 by P1 raised to power gamma minus 1 upon gamma. That is reversible adiabatic process, so easily I can write, right? Yeah, बिल्कुल लिख सकता हूँ. There is no issue on this, and I think we have solved this numerical, right? So बच्चा पार्टी T2 by T1 is already given in the question. T1 given है, that is how much? It's not given. No, it's given 15. That is 288 now. P2 by P1, it is also mentioned. It is how much बच्चा पार्टी? कितना दिया है वो? 5. It is mentioned in the question, that is 5. It is going to be 0.4 divided by 1.4. My dear, you will getting T2, and T2 will come around बच्चा पार्टी. कितना आएगा T2? 456.14. 456.14 Kelvin. So my dear, here we have T2. So T2 we are done with, right? Now my dear, isentropic efficiency. What should be the isentropic efficiency of this compressor? So it is going to be T2 minus T1 is going to be what, my dear? T2 dash minus T1. It is nothing but 0.87. So my dear, you know that T2, you know that T1, you know that you will get T2 dash. So definitely यहाँ पे हमारा T2 dash कितना जाएगा बच्चा? That my T2 dash will be how much? कितना आएगा बच्चा पार्टी? It is going to be 481.26. 481.26 Kelvin. We have T2 dash now. Now my dear, what I have to calculate? I have to calculate work done. मैं क्या calculate कर लूँगा? Work done calculate कर लूँगा. So my dear, work done is going to be, I can write CP, actual work done. So it is definitely T2 dash minus T1. But I know that this CP into T2 dash minus T1 also equal with what, my dear? ये किसके बराबर होगा बच्चा? ये बराबर हो जाएगा UVF tan theta minus tan phi. That is UVF tan of theta minus tan of phi. Right? So definitely ये क्या होगा? CP, that is 1.005. Right? You can say 1005 joule में, not in kilojoule, right? 481.26 minus T1, that is how much? 288 is equal to 170 tan of theta minus tan of phi. So my dear, I'll get tan of theta minus tan of phi. that is going to equal with the किसके equal होगा? It is going to be 0.544 0.54406. It is going to be my tan theta minus tan phi. ये हो गया मेरा tan theta minus tan phi. My dear, if you see that I have done with this, that is tan theta plus tan phi is equal to, अगर मैं इसको A नाम दे दूं and इसको B नाम दे दूं, right? This equation is what? B. So from A and B, I'll get, my dear, मेरे को क्या मिल जाएगा? That I'll get tan theta and tan phi. So tan theta is equal to 0.889. Tan theta क्या आ जाएगा मेरा? That I'll get tan theta is equal to 0.889. I'll get theta and that will be come around to be 41.65. Okay. Now, my dear, if you get tan theta is equal to 0.89, that is theta is equal to 41.65. Now, my dear, I'll get tan phi. So मेरे को tan phi कितना मिलेगा बच्चा पार्टी? I'll get tan phi as well. So my tan phi will be come around कितना आ रहा है? 0.345. That is phi is going to be 19.06. Okay, and this is going to be correct answer. So definitely, my dear, blade angle at inlet exit पे 19.06 correct, and at inlet it is going to be 41.6. That is 1 and 2 is going to be correct. I hope you got it. Now, my dear, again, that which of the following refrigerant designation is correctly indicated, that we have to easily find out. हमें ये बताना है, right? So I want to tell you, I'll give the example. Okay. So first of all, let's see the number one. Number one वाले को देखते हैं. So my dear, this R1 I can write it like this. R011. So my dear, you know that it is going to be M minus 1 is going to be 0. N plus 1 is going to be 1. And my dear, M minus 1, N plus 1, and that is going to be P, I think, right? अरे P होगा ना? Yes, it is going to be P. So P is equal to 1. And my dear, you know that there is another equation, that is N plus P plus Q is equal to what, my dear? Twice M plus 2. So my dear, I can calculate from here. क्या calculate कर लूँगा बच्चा? That I will calculate, I will put the value and I will calculate the value of Q. So M is equal to 1, N is equal to 0, P is equal to 1. So 1 plus Q is equal to, it is equal to 2 plus 2, that is Q is going to be equal with 3. And you know that designation will be CMH, NFP, CLQ. So definitely, my dear, CM, that is going to be 1, C, H, N is 0. So my dear, FP, that is FP is how much? 1. Okay, F we have. CL, and again Q is 3. So that means it is going to be correct. ये correct है. Right? In this way, you can easily find out. Now I'll took the another one. मैं और एक ले लेता हूँ. That is, if I took R134, definitely, my dear, M minus 1 is going to be 1, N plus 1 is going to be 3, and my dear, P is going to be 4. Right? Now I'll put the value that is on this, N plus P, that is N is equal to 2 आ जाएगा. So 2 plus 4 plus Q is equal to twice M plus 2 ना. कितना बचा? Twice M plus 2. So it is got twice M plus 2, right? So twice M plus 2, M is equal to 2, right? M is equal to 2. So that means twice M, that is 2. That means 4 plus 2. My dear, I'll get Q. It will get cancelled out. Q is equal to 0. Q is equal to 0. That means it is going to be, yes, it is going to be what, my dear? CM. So C, that is H. N. N का value भी 2 है. Okay. C2H2 FP, that is 4. That means correct. It is also correct. Now if I see the another one, that is R110. So my dear, in this is what? Unsaturated. So इस पे formula थोड़ा सा अलग होता है. Each and everything will be remain same. The only thing is that it will be little bit different, right? So my dear, let's see. So it will be look like this one, my dear. ये कैसे होता है designation? That is R1, M minus 1, N plus 1, and going to be P. And equation will be what, my dear? Twice M is equal to N plus P plus Q. So my dear, here what I'll get M minus 1 is equal to M. Sorry, I'll get m minus 1 is going to be 1, n plus 1, 1, 5, 1150, and my dear, p is going to be 0. Right now? Yes or no? Of course it should be. My dear, I'll get the value of, so definitely n plus p plus q is equal to twice m. So my dear, n is what? 4, p is 0, q we have to find out, 2 into 2, that is going to be 4. So 4 cancel out. My dear, I'll get q is equal to 0. So if you get q is equal to 0, then my dear, we have formula CMHNFP. CMHNFPCLQ. So C is equal to C2HN. Okay, that means going to be correct. So ये भी right है. In the same fashion, my dear, you can also find out, and this is what organic compound, right? Inorganic compound. So definitely, my dear, क्या हो जाएगा यहाँ पे? यहाँ पे क्या होगा? SO2, that is molecular weight plus 700. So molecular weight is what, my dear? 32 plus 32, that is 64. So 764, that means it is also correct. That means all are correct, right? I am a bacha party, of course it should be. Now, my dear, we'll then go for the next question. एक क्वेश्चन और देखते हैं next question पे. That will move to the next question. So see here. A Breton cycle has a compression ratio of 16:1. Okay, the cycle produces 14 megawatt with an inlet state of 17 degrees centigrade, 100 kilopascal. If the heat added in combustion is 960, heat added in combustion is how much, bacha? 960 kilojoule per kg. Then which of the following statement are true? That means we have to find out, right? Yes or no? So let me calculate one by one each and everything. Okay. So let me draw the TS diagram first. So let me draw the TS diagram over there. यहाँ पे draw करते हैं. Three, 4, right? Clockwise cycle, power plant engineering. TS. This is what, my dear, TS diagram. Okay. Now we'll calculate one by one each and everything. Compression, that is pressure ratio 16. Right? Pressure ratio कितना दिया है बच्चा? That you can do that pressure ratio is what? 16. My dear, I can get T2 by T1 is going to be pressure ratio raised to power gamma minus 1 upon gamma, and T1 is already given. कितना given है बच्चा? 17. That is what, my dear? 17 means how much? 90, 290 Kelvin, right? So my dear, I'll get T2, and that is going to be 290 into what, my dear? 16 raised to power 0.4 divided by 1.4. So definitely, my dear, I'll get T2, and that will come around to be T2 कितना जाएगा बच्चा? 640.37. 640.37 Kelvin. So it is what, T2, right? We got T2. So my dear, once you got T2, you know that आपको, that is Q in is going to be nothing but what, my dear? It is at constant pressure, right? अरे हाँ या ना? So it is what, Cp T3 minus T2. So it is given 960. कितना दिया मैंने? 960, right? Cp 1.005. T3 is how much? T3, that we have to find out. T2, that is 640.37. My dear, I'll get T3 from here. So T3 कितना जाएगा बच्चा? That T3 will come around to be कितना? 1595 and 1595. 1595.6 Kelvin. This is going to be a T3. So my dear, when you got T3, now my dear, W net is given. So W net is given. I can get efficiency. So definitely efficiency is going to be W net divided by heat supplied. So definitely W net is given. That is how much, bacha party? It is nothing but kitna given? It is given how much? It is given 14 into 10 raised to power 6. Let me check. Megawatt, that is watt में करेंगे तो कितना हो जाएगा? 14 into 10 raised to power 6. Heat supplied, that is what, my dear? Heat supplied is how much? It is going to be 960 joule. Kilojoule है, so definitely इसको किस में कर लेंगे? Joule में. Right? Yes or no? Watt में, so definitely you have to multiply by mass for it. Right? But you know that eta is also equal to, eta किसके बराबर होता है ब्रेटॉन का? That is 1 upon rp raised to power, क्या होता है बच्चा? Gamma minus 1 upon gamma. Yes, it is what, my dear? Gamma minus 1 upon gamma. So I will equate it with this. That means 1 minus 1 upon rp. Rp is what, my dear? 16. So 16 raised to power 0.4 divided by 1.4. It is going to be 14 into 10 raised to power 6 divided by mass flow rate multiplied by 960 into 10 raised to power 3. So my dear, I'll get mass flow rate from here. So मुझे mass flow rate कितना मिल जाएगा बच्चा? That I'll get, हाँ जी बच्चा, please tell me. So it is going to be 26.66 kg per second. Okay, that is going to be kg per second, and this is, now let me check. The mass flow rate of air will be 20 to 26.6 right now. This is going to be correct. The highest temperature 1595.6 correct. 1 and 2 both are going to be correct option, right? बच्चा पार्टी, now we'll go for the next. एक न्यूमेरिकल और देखते हैं, अगला न्यूमेरिकल देखते हैं, अगला क्वेश्चन देखते हैं. ओके, सो बच्चा पार्टी, हियर वी सी, देखेंगे ध्यान से. नेक्स्ट क्वेश्चन प्लीज, लुक एट दिस. इस क्वेश्चन को ध्यान से देखें. सो बच्चा पार्टी, what they said, the properties of saturated water stream at two state are given below. Okay, it is given 40 and 50 pe. Temperature is also given, Vf given, Vg given, each and every the property has been given. Using Clausius-Clapeyron equation, the estimated entropy that we have to, entropy change we have to identify by the help of Clausius-Clapeyron. Okay, they have given. Okay, so my dear, now I'll go for the next slide, but before that, let me write the equation. That is dp by dt is nothing but what बच्चा? क्या होता है dp by dt? dp by dt is nothing but what? Latent heat. Latent heat is how much? Latent heat, right? अरे हाँ या ना? That means hfg. That means what? hfg. Okay, I hope you got it. That is latent heat. That is dp by dt is going to be what, my dear? hfg, right? So definitely it should be what, my dear? dp by dt. It is going to be hfg, and hfg is going to be what, my dear? 10 into, हाँ जी बच्चा, क्या होगा? Right? Ayana, yes, anybody have any doubts? Please let me know. कोई भी डाउट होगा, कैसा भी डाउट होगा, you have to ask me. Okay? Divided by 81.317. Right? 81.317 minus 75.857. Okay, I hope you got it, my dear. मैंने क्या करा है, right? So it is going to be what, my dear? 1831.5. ये कितना आ जाएगा हमारा? 1831.5. So if you get this, my dear, now VFG at 40 kilopascal will be average of what? VFG at 40 kilopascal and 50 kilopascal, right? हमें 45 पे फाइंड आउट करना है ना. So we have 40 and 50. So definitely, my dear, VFG क्या होगा? That is going to be average. So 4 point plus 3.2, that is what, my dear? How much? 7.2. 7 point means 2 means what? 3.6. Yes or no? That is VFG at VFG at what, my dear? At 45 is going to be 4 plus 3.2 divided by 2, that is 7.2, that is going to be 3.6, right? 3.6 meter cube per kg, ये मान लीजिए आप unit. Okay, so if you get it, that means now you get it, that VFG, right? Now my dear, SFG, you know that, right? आपको SFG पता है, I can easily, so my dear, see what I'll do. अब मैं क्या कर रहा हूं, देखिए ध्यान से. एंथैल्पी ऑफ वेपराइजेशन. अब if I took ln of P2 by P1, यहां से हम लोग जब कर रहे होंगे, wait a minute guys, that I want to tell you something. Just give me a minute. Okay, let me adjust my table. So bacha party, now we can write the equation, that is Clausius-Clapeyron equation first, so that you have an idea कि हाँ भाई कहाँ से किया है, कहाँ से क्या चीजें उठाई है. ठीक है, so I will write that first. मैं उसको पहले लिख दूंगा. Okay, so here my dear, you can see my dear, देखें ध्यान से. So you know that equation is m is equal to, we have already find out. Okay, you know that my dear, equation क्या होता है, that is Clausius-Clapeyron. Let me write again. You know that dP by dt is going to be what, my dear? Latent heat divided by Tsat, ब्रैकेट में क्या होता है, Vg minus Vf. But right, यही होता है. That means it is what, VFG, right? Tsat and VFG, right? But अगर मैं वैल्यू Tsat की पुट कर दूं, so what I'll get, V को रिप्लेस कर दूं, so what I'll VF को रिप्लेस कर दूं, so my dear, it is going to be dP by dt. Ideal gas equation, right now, ideal gas equation PV is equal to MRT होता है. I'll get V is equal to what, my dear? MRT by P, right? So definitely M तो constant है, so definitely pressure आएगा and RT आएगा, so definitely dP by dt will become latent heat multiplied by P saturated. यहाँ पे क्या हो जाएगा, T saturation का square multiplied by R, right? So my dear, what I'll get dP by P integration is equal to latent heat divided by R integration dt by T square, right ना, यही मिलेगा. So my dear, इसका इंटीग्रेशन क्या जाएगा, ln of P, लिमिट लगेगा 1 से 2, लिमिट विल बी फ्रॉम 1 to 2 ना. So ये क्या हो जाएगा, ln of P2 by P2 minus P1, so definitely ln of P2 by P1, so it is कितना हो जाएगा बच्चा, ये हो जाएगा मेरा 50 by 40. अरे हाँ या ना, ऑफ कोर्स इट शुड बी latent heat by R 1 upon, माइनस कर दो, क्या हो जाएगा बच्चा माइनस में, इट इज गोइंग टू बी, हाँ जी, 348.857 माइनस व्हाट, 1 upon 354.31, 1 upon 354.17, right? My dear, from here you'll get what, latent heat by R आपका जो है, that means you get latent heat ना. R तो 0.287, you can put the value of R will be 0.287. So my dear, यहाँ से क्या मिलेगा, latent heat, and the latent heat will come around to be बच्चा पार्टी 1449.8 kilojoule per kg, and what, my dear? Kelvin भी होगा यूनिट में, remember, हाँ. So my dear, now we'll check out कि कौन कौन सा correct है. The estimated enthalpy of vaporization, this one, the estimated entropy change 6.593, right? 6.593, that means it is going to be how much? नहीं, अभी हमने एंट्रोपी चेंज नहीं कैलकुलेट करा है, राइट? So my dear, let me calculate the entropy change as well. So 45 पे, right? So my dear, see, SFG क्या हो जाएगा? SFG is equal to what, my dear? SFG is going to be dp by dt. Latent heat means what, my dear? SFG. So what I can write? Just see, that is SCG minus SF divided by VG minus VF is going to be equal with, किसके इक्वल होंगे बच्चा पार्टी के? dp by dt के. किसके? dp by dt के. So definitely it is what? SFG by VFG is equal to dp by dt, right? So my dear, now what should be the SFG? SFG क्या होगा? So definitely my dear, SFG क्या हो जाएगा? 1831. ये dp by dt कितना आ गया? dp by dt is how much? कितना है बच्चा पार्टी? You know the dp is what, my dear? 40 to 50, right now. So 10 dt is how much? टेम्परेचर में इतना डिफरेंस है, कैलकुलेट कर लो. सो ये दोनों का रेशियो ले लो. सो माय डियर, जस्ट वेट अ मिनट. 75.8131781 75.857 minus 81.317. okay, okay, 1.315, right? So definitely SFG दिया है ना. हाँ, SFG दिया है, बट वी हैव टू मल्टीप्लाई इट ना. अरे भैया, वो SFG नहीं दिया हुआ है, ये SG और SF है, राइट? बट हमें किस पे फाइंड आउट करना है? ये 45 पे, ये दिए हुए हैं किस पे? 45 किलो पास्कल पे. हियर दे हैव गिवन 40 and 50, सो वी हैव टूक द एवरेज. सो हमने एवरेज लिया है सैम यहाँ पे. कहाँ गया VFG? ये एवरेज लिया है, राइट? सो माय डियर, dp by dt, सो dp कितना आ जाएगा मेरा? 10, एंड इट इज गोइंग टू बी, ये पूरा डिफरेंस लेंगे. किसका डिफरेंस? किसका लेंगे? दोनों का. 75 माइनस 81 माइनस 81.317 माइनस 75.857 multiplied by VFG. VFG कितना है बच्चा? That we have already calculated 3.6. So my dear, now you'll get SFG, और SFG आपका आ जाएगा, that will come around, that is 6.6. कितना आएगा? 6.6 kilojoule per kg Kelvin. But my dear, now this SFG is nothing but what, my dear? SCG minus SF, that is what? Change in entropy. So my dear, my option is going to be, that is estimated entropy change will be what, my dear? 45 kilopascal पे क्या है मेरा? 6.6, that means what? 6.593, that means approximately equal. So 1 and 2 is going to be correct, right? I hope you got it. सॉम समझ आ गई? सैम, आई होप समझ में आ गया होगा. ओके, अब आगे चलते हैं. सो दिस इज अ वेरी गुड न्यूमेरिकल, ये भी अच्छा न्यूमेरिकल था. नाउ माय डियर, विल कम टू द नेक्स्ट वन. अभी एक अगले पे आ गए, दैट इज विच ऑफ द फॉलोइंग स्टेटमेंट आर ट्रू रिगार्डिंग थर्ड लॉ ऑफ थर्मोडायनामिक्स. थर्ड लॉ ऑफ थर्मोडायनामिक्स के रिगार्डिंग कौन सा स्टेटमेंट करेक्ट है? यस सैम, आंसर करो इसका. सो सी, entropy change associated with any condensed system undergoing a reversible isothermal process approaches zero as temperature at which it perform approaches 0 Kelvin. correct, ये तो बिल्कुल correct है. okay, it is possible to reduce the entropy of a system to its absolute zero value in a finite number of operation. no, it's incorrect. आप zero नहीं कर पाओगे. absolute zero is not achievable. If the composite of two thermodynamic system constitutes isolated system, then any energy exchange in any form between those two systems is not bounded. No, it's bounded. It's bounded. Okay, that means isolated है तो पक्का bounded होगा. So it is incorrect. The entropy of a system approaches a constant value as its temperature approaches absolute zero. correct. जैसे जैसे absolute zero, definitely उसका value क्या होता जाएगा? constant होते जाएगा, right? So it is going to be 1 and 4 is going to be correct. both 1 and 4 दोनों correct होंगे सैम. Remember, हाँ, दोनों correct होंगे. I repeat कि दोनों correct होंगे. ठीक है, अब आगे बढ़ते हैं। The speed of axial flow compressor is 15,000 rpm. Okay, and mean dia 0.6 meter. Axial flow velocity is 225 meter per second. Wall component 85 meter per second. The work done is 45. Stage inlet condition are 1 bar 300 Kelvin. Assuming isentropic efficiency 0.89%. यहाँ पे डिफ्लेक्शन एंगल पूछा है. डिफ्लेक्शन एंगल मींस व्हाट माय डियर? थीटा माइनस 5 पूछा है हमसे. क्या पूछा है? थीटा माइनस 5. ओके, थीटा माइनस 5 पूछा है हमसे. सो हाउ वी कैन कैलकुलेट थीटा माइनस 5 माय डियर? ये कल सेम न्यूमेरिकल हमने करा हुआ है. द यस्टरडेज क्लास वी हैव डन द सेम न्यूमेरिकल, राइट? कल की क्लास में हमने इसको करा हुआ है. सो यू जस्ट गो थ्रू द यस्टरडेज वीडियो, डेफिनेटली विल फाइंड द सेम न्यूमेरिकल. यही सेम न्यूमेरिकल करा है. सो आई विल नॉट टुक इट. अब इसको आगे फिर से नहीं लूंगा मैं, because it is already repeated. Right now my dear, we'll go for the next. I hope it's visible to you. आपको visible होगा completely, so that's great thing. So listen to me. A steam power plant, the steam turbine is designed to operate between pressure of 10 megapascal and 20 megapascal. The steam turbine and blades are manufactured using a specific material that can withstand a higher temperature of 3000 Kelvin. Okay, vapor state, but due to corrosion at exit, the blades cannot withstand the quality more than 0.77. Okay, 0.77. The properties are mentioned below for 1 kg, that it is a dryness fraction is given. Okay, 0.77. 1 kg of fuel and safe working of turbine. Each and every condition is mentioned. Now you have to calculate these parameters and you have to tell me which option is going to be correct. कौन सा option correct होगा और कौन सा गलत होगा, ये बताना है. Okay, इजीली कर लेंगे इसको भी, बहुत आसानी से कर लेंगे. डोंट नो काइंड ऑफ फियर मत लेना कि इतना बड़ा क्वेश्चन है तो डेफिनेटली नहीं बनेगा. ऐसा कुछ नहीं है, बहुत बहुत आसान काम है इसका, बहुत ही आसान. लेट मी टेल, मैं बताता हूँ आपको कैसे आसान है इतना. आई टेल यू. देखो इधर रैंकाइन साइकिल है, स्टीम टरबाइन है, तो लेट मी ड्रॉ द डायग्राम. ओके, ओके, it's going to be 1 2 3 4. TS, राइट ना? ओके, ध्यान से देखेंगे. It's very easy. Now what they said, the maximum temperature possible in the steam turbine is 420. So definitely हमें find out क्या करना है? T1, right? T1 we have to identify, right? So definitely my dear, look at this. P1 P4 we know that. P1 क्या है, P4 क्या है, that we know that. P4 is equal to P1 is equal to 10 megapascal, right? P2 P3 कितना है? 20 kilopascal. That means यहाँ पे P1 P4 क्या हो जाएगा बच्चा? 10 megapascal. और P2 is equal to P3, that is equal to what my dear? 20 kilopascal. It is mentioned in the question. ये देखो, right? Now listen to me my dear. अभी हम क्या करेंगे? That we going to calculate H1 and H2, right? H2 calculate करेंगे, right? So my dear, H2 is directly given. H2 क्या है? Directly given नहीं है. So we can go to calculate H2 is equal to what my dear? HF2 plus X2 HFG2. HFG2 मतलब Hg2 minus HF2. So HF2, right? HF2 मतलब कौन से प्रेशर पे? 20 किलो पास्कल, दैट इज 0.02 मेगा पास्कल. ये क्या होगा? 0.02 मेगा पास्कल होगा, राइट? सो इट इज व्हाट माय डियर? HF2 इज व्हाट? 251.42. क्या होगा? 251.42 प्लस 0.77 and you can just do the minus, right? So बच्चा पार्टी here 251.42 plus 0.77 bracket में how much Hg is what 2725 251.42, so it is going to be 2066.68. This is what my dear S2 आपकी S2 आ गई. Now my dear easily I can calculate S2 as well. मैं S2 भी calculate कर लूंगा. S2 is going to be SF2 plus X2 and what SFG2. So my dear SF2 is going to be कितना है बच्चा? SF2 that is this one, that is 0.83202 0.83202 plus 0.77 SG2 minus SF2. SG2 is what? 7.9072. 7.9072 minus SF2. SF2 0.83202. So my dear, you will get the answer and answer will come around. कितना आएगा बच्चा ये आंसर? 6.302 kilojoule per kg Kelvin. So my dear, we have S2 as well. हमारे पास S2 भी है, right? My dear, from the diagram, I can say S1 is going to be S2 is going to be 6.302 kilojoule per kg Kelvin, right? Yes or no? I can easily say, my dear, right? State 1 क्या है? Superheated है at 10 megapascal पे, right? Yes or no? And T is what? 420 degrees centigrade. Entropy is what? 6.302, right? Right now, so my dear, see. H1 is superheated at 10 megapascal. It is at 10 megapascal, right? So my dear, now I calculate what? Temperature. So temperature कैसे calculate करेंगे आप? Temperature, my dear, and let me check. 6.3020. We have entropy, that is what, my dear, 6.3020, and how much we have? 6.3020, right? So ये match कर रहा है, that means our temperature is going to be what, my dear? 420. Right now, as we have calculated, and our S is what, my dear? Our S is going to be 6.302 kilojoule per kg Kelvin. So definitely in this table we can get temperature. So temperature क्या हो जाएगा? 420. So my dear, temperature at T1. So T1 पे temperature क्या हो जाएगा? 420 degrees centigrade. I hope you got it. कि temperature, how we have find out temperature, right? Temperature we got it. Now my dear, what should be the enthalpy? Enthalpy क्या होगी उस point पे? So you can check it out. Enthalpy is what, my dear? H is going to be 3157.5. So my dear, again I can write H1 is going to be 3157.5 kilojoule per kg. So we got T1, we got H1, right, my dear? So definitely maximum possible work output क्या हो जाएगा बच्चा? M into H1 minus H2. Possible work क्या हो जाएगा? It is going to be what, my dear? Mass flow rate H1 minus H2. So mass flow rate that is given in the question, and that is how much बच्चा? It is 1. Explain कर, see. आपने S find out कर ली. You have already find out S1 6. I hope yes यहाँ समझ में आ गया. Sam, please type S if you get it. Then please type yes for S. Just type S for sun. If you get it this line, कि ये जो line मैं blue line से मार्क कर रहा हूँ, had you got it this? ये चीज समझ आई? Yes or no? If you get this, because 6.302, so what I'll do? What I will do, I will go to this another table. In that there is an entropy, that is 6.302. So इसके corresponding enthalpy is what? That is this much. That is enthalpy. That is ये कौन से point की enthalpy होगी? H1 की. And my dear, this is going to be temperature T1. T1 is what, my dear? 420. राइट ना. T1 क्या हो गया 420 हो गया. सो डेफिनेटली वी हैव ऑलरेडी दैट, वही चीज तो लिखी है यहाँ पे. The same thing we have written over here, T1 420 and my dear H1 is going to be 3157.5, right? So possible work क्या होगा H1 minus H2. So my dear mass flow rate is 1. Mass flow rate is 1. This is H1. H1 we have already find out 3157.5 minus 2066.68. My dear, I'll get the answer and answer will be around कितना आएगा बच्चा 1090.8 kilojoule. 1090.8 kilojoule, right? Okay. So megajoule में क्या हो जाएगा बच्चा? Megajoule में it is going to be 1.09 megajoule, right? Okay. So maximum entropy change in condenser पूछा है, right? So maximum entropy change in condenser means what, my dear? Condenser कौन सा होगा? It is going to be 2 and 3. So definitely M into, let me, so entropy change in condenser, mass flow rate S2 minus S3. So definitely my dear, ये क्या होगा? What is the value of it? M is going to be 1, right? M is going to be 1. Am I right now? So definitely my dear, 1 into 6.302, we have already find out S2. S2 तो हमें पता ही है, but S3, how we can get S3? So my dear, S3 is nothing but what? In a saturated liquid line. So definitely my dear, it is going to be SF. SF at what? 0.02 megapascal. So definitely SF is 0.83202. So 0.83202. So my dear, I'll get the answer. My answer will be around 5.47. 5.47 kilojoule per kg, not kg, because here we have taken mass, so definitely kg नहीं रहेगा, per Kelvin हो जाएगा. Okay, kilojoule per Kelvin. It is delta change in entropy during in condenser, right? Sam, had you got it now? Sam, अब समझ में आ गई चीजें? So my dear, which option is going to be correct? Let me. The maximum temperature 420 correct है. The maximum work output possible from steam turbine 1.09 megajoule, it's also correct. The maximum change in entropy possible in condenser 5.47, correct, I think. Yes. The maximum temperature possible, no, that means 1, 2, 3 is going to be correct. 3 statement correct होंगे. This is a new category of questions which has been introduced by the IIT Bombay. Okay, I hope you got it. Now my dear, we'll go for the next. और आगे चलेंगे. We'll see this one. इसको देखेंगे अभी. If 1 kg of nitrogen gas goes from state 1, that is 100 kilopascal and 100 Kelvin, to state second, that is 580 kilopascal and 150 Kelvin, through a thermodynamic process, then the process is देखो यहाँ पे temperature भी change है, pressure भी change है. The process is adiabatic, the process is polytropic, the work done on the gas is this much, the work done on the gas is this much. Which statement is going to be correct, that we have to tell? मैं दैट्स व्हाई दैट आई ऑलरेडी टोल्ड यू सैम, मैं जब से आपके एसएससी जेई की भी क्लासेस दे रहा हूँ उस टाइप पे मैंने बोला था आपको कि आपको जो है मैंने आपको पहले भी बताया था कि दैट यू हैव टू बी केयरफुल विद द डायग्राम. डायग्राम आपको आनी ही चाहिए बिकॉज इट्स अ हार्ट. ओके, डायग्राम नहीं आएगा तो हाउ यू कैन सॉल्व माय डियर, कैसे सॉल्व कर पाओगे फिर आप? ओके, सो डायग्राम इज मस्ट. ओके माय डियर, सो सी हियर, अब देखें आगे, देखते हैं. ओके, सो लेट्स सी कि क्या होता है. सपोज टू बी प्रोसेस इज आइडियाबैटिक. सो अगर हम इसको मान लेते हैं पॉलीट्रॉपिक है प्रोसेस. If I say that process is polytropic, supposed to be, let's check. So definitely it is polytropic. Then I can easily write what I am assuming. I am assuming that the process polytropic होगा, right? So T2 by T1 is going to be what, my dear? P2 by P1 raised to power n minus 1. Gamma नहीं आएगा, n minus 1 upon n, right now? अरे हाँ या ना बच्चा पार्टी? Yes, of course. So definitely my dear, T2 is what? 150. T1 is what? 100. P2 is what, my dear? P2 is what? 580. P1 is what? 100 raised to power. Now we'll check n का वैल्यू अगर यहां से हमें मिल जाता है 1.3, so my dear definitely हम कह देंगे कि हाँ it is what? It is nothing but what, my dear? So देखो ध्यान से, so my dear यहां पे हमें मिलता है that is n minus 1, यहां पे n minus 1 upon n, that is log of, we have taken log to the base 5.8, किसका किसका लेकिन that is 1.5 का, ये जो 1.5 आएगा इसका, so ये कितना आ रहा है बच्चा? That from here you will get n कितना आ रहा है? 1.29, वो जो approximately किसके बराबर है? 1.3. so definitely ये तो करेक्ट हो गया, पहला तो करेक्ट हो गया. वर्क डन ऑन द गैस, so polytropic में क्या होता है? that you know that W polytropic, let's check कि polytropic में work done कितना आएगा. so it should be what, my dear? MRT है ना? अरे P1 V1 minus P2 V2 होता है. so what I'll do, I will do P1 V1 को replace कर दूंगा मैं. so I will replace P1 V1. you know that, my dear, P1 V1 minus P2 V2 divided by n minus 1 होता है. so what I'll do, I will replace P1 V1 by what? MR T1. so definitely ये T1 आ गया, यहाँ पे आ जाएगा T2, MR common, n is 1.3 minus 1, you can put the value, get the answer. M is 1, R is what? 0.287, T1 that is I think कितना है T1? T1 is going to be 100 and that is 150. So 100 minus 150 divided by 0.3. So my dear, I'll get the answer, and answer will comes around, बच्चा पार्टी कितना आ रहा है ये? It is how much? Yes. So it is going to be minus 47.83. Minus 47.83 kilojoule. So definitely, my dear, it is nothing but work done on the gas. ये work done on the gas है, ना कि work done by the gas. Sam, समझ आ रहा होगा? So now we'll check, देखेंगे फिर से. Work done on the gas, yes. Work done on the gas. See देखो यहाँ पे जब on लगा है तो there is no need of minus sign, तो ये तो incorrect हो गया. So definitely, but see here is the on, but यहाँ पे minus नहीं आएगा, यहाँ पे फिर minus नहीं आएगा. So option number 1 and 2 and 4 is going to be correct. ठीक है? I hope you got it now. My dear, we'll go ahead और आगे चलते हैं. तो देखो इधर ध्यान से, that is air enters an adiabatic nozzle of 400 kilopascal pressure, 900 Kelvin temperature with a negligible velocity, that is V1 is going to be 0. The flow is ideal, exit pressure 100 kilopascal, then exit temperature, exit velocity, that is exit temperature and exit velocity that you have to find out, then and only you are able to mark the correct answer, right? Sam, I hope you got it. Sam समझ आ रही है चीजें कि नहीं आ रही? I hope you're getting. Supposed to be this is my nozzle. ये मेरा क्या हो गया? जल. कौन सा जल? गंगा जल नहीं, नोजल. Supposed to be section 1 है, section 2 है. यहाँ से गए, right? My dear, can I say, because यहाँ पे adiabatic होगा, right ना? Adiabatic flow, so definitely I can say T2 by T1 is going to be P2 by P1 raised to power gamma minus 1 upon gamma. So definitely, my dear, मुझे क्या मिल जाएगा? T2 मिल जाएगा यहाँ से. P2 by P1 is given. T1 is what? T1 is 900. P2 that is how much? 100 by 4 raised to power gamma minus 1. Gamma minus 1 means what? 0.4. So my dear, we'll get T2, and T2 कितना आ रहा है बच्चा? That your T2 becomes 605.7. राइट? कहने का मतलब ये ऑप्शन तो करेक्ट हो गया, राइट ना? अब आपसे क्या पूछा है? एग्जिट वेलोसिटी के बारे में पूछा है, राइट? तो यू नो दैट माय डियर, वी हैव ऑलरेडी डन दिस. इसको हम कर चुके हैं, बहुत अच्छे से किया था हमने, राइट? सो लेट मी राइट once again. My dear, you know that V2 is going to be what, my dear? 2 into H1 minus H2 ब्रैकेट में, आया ना, right? So and we have to multiply it by what, 1000, because it is in going to be kilojoule. So definitely my dear ये क्या हो जाएगा, अंडर रूट 2 into h1, that is cp. So cp बाहर ले लेंगे, don't worry. t1 is how much? t1 is going to be 900, t2 605.7. 900 minus 605.7 multiplied by 1.005 multiplied by 1000. So yes my dear, now you get the answer. आपको क्या मिल जाएगा, आंसर मिल जाएगा, and my dear that answer will be 769.11. 769.11 meter per second, and this is going to be your required answer. So definitely v2 क्या हो जाएगा, 605 point, what is the answer, 769, that means this one. So option number 1 and 4 is going to be correct. Yes Sam, it is going to be option number 1 is going to be correct. I hope you got it. So बच्चा पार्टी और आगे बढ़ते हैं और इसको आगे लेके चलते हैं. सी, in a Bell-Coleman's refrigeration plant, air enters the compressor at pressure of 1 bar at temperature of 10 degrees centigrade. It is then compressed to a pressure of 5 bar. Air is then cooled to 25 degrees centigrade in the cooler. Assume both compression and expansion to be isentropic, having the value of gamma 1.4 Cp given. Now, my dear, theoretical COP, refrigeration effect, theoretical COP and refrigeration effect. That means we have to calculate theoretical COP, and my dear, we have to calculate the refrigeration effect, right? So we can easily do it. हम इसको बहुत easily कर लेंगे. So, but before that, let me draw the diagram so that you have a better idea कि हाँ यहाँ पे क्या करना है. So, my dear, see. What should be the diagram? So diagram will be like this. One, two, three, four, right? It is going to be TS diagram. क्या है ये? ये TS diagram है. ये क्या है बच्चा? It is going to be TS diagram. Right now? So it is going to be, my dear, COP of ideal cycle. COP of ideal cycle, that is theoretical, that is going to be 1 minus 1 upon RP raised to power gamma minus 1 upon gamma. That you know that, right? यही है. Sorry that I have written for Breton, I'm very sorry. ये like this. हाँ यही तो होता है ना. It is like this, 1 upon 1 minus. That means the same thing is there. 1 minus 1 upon RP raised to power gamma minus 1 upon gamma. Right? बच्चा पार्टी? Yes, of course it is. ऐसा ही होता है. Now my dear, look at this. Look at me. So yes बच्चा, let me write it again once again. थोड़ा सा अच्छे से लिखते हैं इसको. 1 upon RP raised to power gamma minus 1, sorry, gamma minus 1 upon gamma minus 1, right? Right now, COB ideal, right? Just give me a minute. Okay, बच्चा पार्टी, give me a minute. Now listen to me. So COP ideal यही होगा. Once we get the COP ideal, my dear, now listen to me. It is COP ideal यही हो गया. So how we can calculate? So my dear, ये हमारा कितना आ जाएगा? 5 we have, right? It is what? it is what divided by 1 upon 5 raised to power 0.4 divided by 1.4 minus 1. So we are going to get this. कितना आएगा बच्चा? It is going to be 1.71. It is going to be 1.71, right? So my dear, we have COP. COP आ गया. Now listen to me very carefully. Can I say like this? That is, can I say T2 by T1 is going to be what, my dear? Pressure ratio raised to power gamma minus 1 upon gamma. Again, so definitely मेरे को T2 मिल जाएगा यहाँ से. T1 I know that. T1 कितना है बच्चा पार्टी? T1 is how much? T1 is given 10. 10 means what? 283. So I'll get T2, and that T2 will come around to be, my dear, what? 283 into 5 raised to power 0.4 divided by 1.4. So it is going to be what, my dear? कितना आएगा ये बच्चा पार्टी? It is going to be 448.22. 448.22 Kelvin. Right? It is going to be T2. ये क्या है बच्चा हमारा? T2 है. Okay. So if you get T2, now my dear listen to me. अगर ये T2 है हमारा, so if you get T2, now my dear you can proceed further and you can calculate what? T4, right? So that you are able to calculate the WE, right? So my dear, you know that there is a one formula, that is even odd that I already explained, T1 T3. So T2 you know that, T1 you know that, T3 had you, yes, T3 you know that right now. 448.22 given है question में, right now कि नहीं given? बच्चा पार्टी please tell me. T3 you can get it, yes or no? अच्छा पार्टी प्लीज लेट मी नो. हाँ जी, राइट. सो यू कैन गेट द T3. सो T3 कैसे कैलकुलेट करेंगे? T3 यू कैन गेट T3 by T4 ना. सो डेफिनेटली T3 by, यहाँ से हमें क्या मिल जाएगा? T4 मिला, बट स्टिल द T3 is missing, right? So how we can get T3? Or T3 is mentioned in the question. We have already calculated T2. T2 हमने कैलकुलेट कर लिया है. It is 448.22. And my dear, T3 is how much? T3 is how much? 298 is given, I think, right? 298 given तो है क्वेश्चन में. 15 डिग्री सेंटीग्रेड क्वेश्चन में ही given है. It is given 25. Here is cooled, then that is this 25. That is 298, right? So that means we are going to get, my dear, T4. T4 यहाँ से कितना आ जाएगा बच्चा? And that T4 will get, my dear, 188.15. 188.15 Kelvin, right? So if you get T4, अगर आपको T4 भी मिल गया, so my dear, now you have work of compression required, that is WC is going to be Cp into T2 minus T1. So my dear, WC is going to be Cp, you know that 1.005. T2 you have already calculated. T2 you have already calculated now. T2 448. And my dear, T1 you know that 283. So you get the answer. WC will come around to be bacha party 166.04. 166.04. Now my dear, work done, work output in expansion will be what bacha party? वो कितना होगा? Cp T3 minus T4. Cp again it's T3 minus T4. So ये हो जाएगा हमारा बच्चा 1.005. T3 you have recently calculated, that is sorry given 298, and T4 that is 188.14. So it is what, my dear, Cp. तो ये कितना आ जाएगा बच्चा? ये हमारा आ जाएगा, that is directly 110.39. 110.39 किलोजूल पर kg. So you got We as well. So definitely मेरे को यहाँ से मिल जाएगा W net, and I can easily get. So my dear, you know that COP is going to be refrigeration effect divided by WC minus WE. So it is going to be 1.71 RE that we have to find out, and it is WC is how much bacha? It is going to be 166.04 minus 110.39. So my dear, I'll get refrigeration effect, and that is going to be रेफ्रिजरेशन इफेक्ट कितना आएगा बच्चा पार्टी 95.24 95.24 kilojoule per kg. I hope you got it. This is what, my dear? This is a refrigeration effect. Okay. So now bacha party will go for the next numerical. एक और numerical देखेंगे, but before that I want to let you know few things. इसमें से will tick or will select the correct answer. Correct answer कौन सा है इसमें? Let's check कर लेते हैं. That is what, my dear? It is correct. 95 point. Let me check कितना है. 24 kilojoule per kg. That means this much. Okay, 92 नहीं 95. Okay. So bacha party will go for next. Yes. I hope it's visible to you. I hope ये visible होगा आपको. Right now? Bacha party, yes. I hope it's visible to you. So here I go. So bacha party, here what they said. A gas turbine system uses regenerator as well as reheating. Regeneration भी use हुआ है, reheating भी है, and intercooling as well, as shown in the figure. Figure में दिख रहा है. The system has two stages of compression, two stages of expansion. That means there is a two compressor, there is a two turbines. Okay, at 100 kilopascal and 17 degrees centigrade. Pressure ratio across each compressor is 4. That means P2 by P1 and, my dear, P4 by P3 is what? 4. Each combustion chamber 300 kilojoule per kg of heat is added. That means ये जो combustion chamber दिख रहा है यहाँ पे दोनों में कितना heat add हुआ है 300 kilojoule per kg. And air regenerator increases the temperature of the cold air by 20 degrees centigrade. That means the temperature increased by the regenerator to that air is what, my dear? 20 degrees centigrade. Assume isentropic operation for all compressor and turbine stages and constant specific properties at room temperature पे assume करना है. So बच्चा पार्टी listen to me very carefully. Thermal efficiency and heat rejection that we have to calculate, right? So बच्चा पार्टी before going ahead मैं आपको just don't worry. Just wait a minute, my dear. Okay. Just wait a minute. So my dear, just see here. A gas turbine. Okay, that is already I already to explain. So my dear, I'll go ahead. Okay, मैं अभी आगे चलता हूँ. Then I'll tell you. This how this happens, my dear. Okay, so see here. Just give me a minute, my dear. Give me a minute. Give me a minute, my dear. Okay. Okay. So here I go. So first of all, let's draw the diagram and then we proceed. Okay, so that we have a clear cut idea कि क्या चीजें हो रही हैं इसमें. So let me draw the diagram first. Okay, so it is what, my dear? Temperature entropy diagram. Okay. Temperature entropy diagram, and that will be like this. Let me draw. This is supposed to be 1, right? So 3 भी यहीं पे आनी चाहिए, right? ना? Wait a minute. Okay, just wait a minute, my dear. This is what 1, 2, 3, 4, 5, 6, 7, 8. Okay, TS. Now, my dear, listen to me very carefully. ध्यान से देखेंगे. Okay, अभी देखेंगे. So here we go. So yes, still we have not given 7, 8, right? And my dear, there is a regenerator as well. So we have to mark regenerator point as well. Okay, so that I forget. So my dear, again I'll give the numbering. Okay, मैं फिर से numbering दे देता हूँ. 1, 2, sorry, it's 1, 2, 3, 4. Here supposed to be 5. यहाँ पे 6, here 7, here 8, here 9, and my dear, here we have 10. Regenerator is there, right? So in this way the cycle is happening. ऐसे कुछ cycle we have. In this kind of a cycle we have, right? अच्छा buddy, there is a regeneration, there is a reheating, everything. Reheating देखो यहाँ पे हो रहा है. Intercooling is that been done, right? 2 stage of compression, it's done, my dear. Okay, so now listen to me very carefully, my dear. T2 is going to be equal with T4, right? This T2 is going to be equal with T4. ये इक्वल होगा. दैट इज थोड़ा सा ऊपर लेना पड़ेगा डायग्राम में भी. वेट, दैट इज T2 is going to be equal with T4, right? हाँ या ना? ऑफ कोर्स इक्वल होगा, दोनों सेम होंगे, राइट? 7 and 9 भी also equal. T7 is equal to T9 as well, right? Yes or no? दोनों थोड़ा सा डिफरेंस होगा, बट T2 is equal to T4, right? So बच्चा पार्टी, लेट मी राइट इज अगेन. थोड़ा सा मैं डायग्राम को और वो कर देता हूँ, so that so see. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my dear, you know that T2 is going to be equal with T4, right? T2 is equal to T4. So definitely my dear, T2 is equal to T4 is equal to क्या हो जाएगा बच्चा? That is T2 is equal to T4 is equal to T1 into pressure ratio raised to power gamma minus 1 upon gamma. So my dear, I'll get T2 is equal to T4 is equal to how much, bacha? Just put the value. T1 is what, my dear? 273 plus 17. That is what? 290. Right now? And there is RP is given 4. RP कितना दिया है? 4. So definitely आपका आंसर क्या आ जाएगा? 430.9. Gamma 1.4. Right now? I 17 दिया हुआ है, देखो यहाँ पे. So you get T2 is equal to T4. If you get this one, then my dear, can I say T5 is equal to T5 is equal to what? 20 degree दे रहा है. So definitely it is what, my dear? 450.9 Kelvin, right? I got T5 as well. T5 भी मिल गया. So definitely my dear, heat supplied will be what? Heat supplied will be what, my dear? Cp T6 minus T5. अरे हाँ या ना? Of course it should be. So definitely it is how much? ये कितना दिया हुआ है? 300. It is given 300 in the question. You can see 300 heat supply हुआ है, right? So I have put it 300. Cp is going to be 1.005. T6 as it is. T5 450. So my dear, you will get T6 and that will come around बच्चा कितना आएगा T6 T6 749.4 749.4 Kelvin. So we have T6 as well. T6 आ गया. Now my dear, same rate, that is in the same way that I can write 6 7 is again isentropic. So I can write T7 is going to be T6 multiplied by Rp raised to power gamma minus 1 upon gamma. Right now? Yes. Sorry, it is going to be, I'm very sorry, that is T6 होगा. ये क्या हो जाएगा 1 upon Rp. 1 upon Rp. Right now? I'm very sorry for this. So T7, T6 that you have. So T6 आपने calculate करा 749. RP you have 4, gamma you get T7 and that T7 will come around 504.3. कितना आएगा बच्चा ये आ जाएगा 504.3 Kelvin. So in this way we get T7 as well. So T7 भी आ गया. Right. What else remains? My dear, T8 we can find out. T8 we can find out. Right. So see here. So my dear, Q in, the heat supplied again will be what? Is again at constant pressure, right? It is what? T8 minus T7. So यहाँ से I'll get T8. So T8 will come around बच्चा पार्टी कितना आएगी ये? 802.8. Okay. So it is again T8. Now my dear, we can get T9 as well. So similarly, my dear, T9 is going to be T8 multiplied by 1 upon pressure ratio raised to power gamma minus 1 upon gamma. Right? I hope everybody got it, that how I'm writing this equation. Right? So bacha party here, I will get T9. So T9 will be what bacha? Kitna aega T9? T8. Right? T8. So T8, you know that 8 not 2.8, right? So my dear, I can easily write RP, you know that, gamma, you know that. So my dear, T9 will be around कितना आएगा बच्चा? T9 540.2. Okay, T9, I hope you got it. Okay, T9 मिल चुका. So my dear, T10 will be what? T10 will be what, my dear? T10 will be what, my dear? T9 minus 20 degrees कम होगा. That means what is going to be 520.2 Kelvin. It is going to be T10. So T10 भी आपके पास में है, right? So total heat supplied will be what, my dear? QS total is going to be 300 multiplied by 2. That is going to be 600, right? Kilojoule per kg. Right now, it's kilojoule only. Kilojoule. I hope you got it. So my dear, Q rejected will be what? So Q rejected total will be what, my dear? CP. CP, yes, CP. T10 minus T1. I will tell you that how I'm counting. Plus CP, T2 minus T3. I'll show in the diagram, don't worry. My dear, here. Heat rejection placed from 2 to 3. So definitely it is what? T2 minus CP into T2 minus T3. Again, the heat rejection will take from 10 to 1. Right now? So again, I have written the same thing. So my dear, T10 will, Q rejection will be 1.005 minus T1. T1 is how much? T1 is how much, bacha party? Just wait a minute. T1 is how much? T1 is already given in the question, and that is nothing but 290. That is 17 degrees centigrade diya tha. That is 290 plus CP, that is 1.005 bracket. Again T2, and that T2 is nothing but what, my dear? 430.9. It is 430.9 minus 290. I'll get the answer. So my dear, Q rejection will be bacha party how much? ये कितना आ जाएगा बच्चा? That will get me around, that is 373 kilojoule per kg. It is what, my dear? 373 kilojoule per kg. Okay, this is what Q rejection. So my dear, thermal efficiency क्या हो जाएगा बच्चा? that I have thermal efficiency, that is eta thermal is going to be what, my dear? Q rejected minus Q supplied. So Q supplied, that you know, Q supplied कितना है? Q supplied is what, my dear? कितना है total? Here I have find out now. 600. Rejected 373 divided by 600. I'll get the answer, and that answer will come around to be 0.378. So this is going to be required answer. So my dear, now check which option is going to be correct. So definitely, my dear, it's correct. Thermal efficiency to itna hi hoga. Heat rejected will be 373. It's also correct. That is option number 1 and 3 is going to be correct. Okay. जो ऑप्शन नंबर 1 and 3 है वो करेक्ट होंगे. दैट वी हैव टू कीप इन माइंड. ओके. नाउ बच्चा पार्टी विल गो फॉर नेक्स्ट. नेक्स्ट मेरे को सी. Consider a gas turbine power plant operating on a simple Breton cycle between a pressure limits of 100 kilopascal and 700 kilopascal. Air enters the compressor at 30 degrees centigrade with a rate of 12.6 kg per second and leaves at 260 degrees centigrade. Okay. Now this air and diesel fuel with an air fuel ratio of 60 are burned in a combustion chamber with a combustion efficiency of 97%. Diesel has the heating value of 42,000 kilojoule per kg. Combustion gases leaves the combustion chamber and enters the turbine whose isentropic efficiency is 85%. Treat the combustion gases as air with Cp 1.093 kilojoule per kg Kelvin. Cv is going to be this and gamma is going to be this. Then, my dear, back work ratio we have to identify, and we have to find out the second law of efficiency as well, so that we can compare the performance, right? So बच्चा पार्टी will do it वन बाई वन. इसको इजीली कर लेंगे. बहुत ये भी आसान है, सिंपल है, नथिंग यू नो काइंड ऑफ कोई क्रिटिकलिटी नहीं है. वी कैन इजीली फाइंड आउट. जस्ट वी हैव टू ड्रॉ द डायग्राम. You should know, the only condition is that you should know the diagram. So it is what? Gas turbine, that means Breton cycle. So let me draw the Breton cycle first. मैं Breton cycle draw कर लेता हूँ. And they have given what? They have given what, my dear? Isentropic efficiency, right? Let me check. Combustion efficiency 97%. Okay. Isentropic efficiency of turbine 55. Okay. So I'll draw according to that. So my dear, see. Okay. Bachawati, listen to me. So it is going to be 1, 2, 3 is going to be 4-4. Right? Now listen to me very carefully. It is what, my dear? It is temperature entropy diagram. Okay. So now we're going to start. So my dear, let's start. So total mass क्या हो जाएगा बच्चा? First of all, calculate the total mass. Mass for a total mass. So it is going to be mass of air plus what, my dear? Mass of air हो जाएगा plus mass of fuel. Plus mass of fuel ना. So definitely इसको क्या लिख सकते हैं? Mass of air. ये mass of fuel को in terms of अगर air लिखना हो तो what I can write, my dear? Mass of air divided by air fuel ratio. Right ना? Mass of air, right, divided by air fuel ratio. So my dear, what I'll get? कितना दिया है मेरे पास क्वेश्चन में? 12.6 divided by 12.6. ये दिया है 12.6 plus 12.6 divided by, it is given 60. You can check it out. यहाँ 60 बोला, ये देखो. Right now? So my dear, you'll get total mass, and total mass for it is given, that is 12.81 kg per second. Okay. So my dear, we are done with the total mass. Now my dear, rate of heat input. Heat input कितना होगा? हाँ जी बच्चा. So it is nothing but the heat supplied. Heat supplied will be what, my dear? Mass flow rate multiplied by mass of fuel multiplied by what? Calorific value. Right? So definitely, my dear, कितना हो जाएगा? QS is going to be कितना है बच्चा पार्टी है? 0.21. Mass of fuel is what? 0.21 आएगा. 0.21 mass of air, that is mass of air, that is 12.6. Wait, mass of fuel is going to be mass of air divided by air fuel ratio multiplied by CV. So ये आ जाएगा बच्चा पार्टी आपका कितना? CV कितना दिया हुआ है क्वेश्चन में? That is 42,000. It is given. ये देखो, right now. So I can get QS. So that QS will come around to be बच्चा पार्टी 8,555. And again we have combustion efficiency as well. So multiplied by eta of combustion, that I forget, sorry, eta of combustion chamber, that is 0.97. It is given. So बचा पार्टी ये कितना आएगा हमारा? 8,555 kilowatt. It is going to be 8,555 kilowatt. Right? I hope you are getting, my dear. सबको समझ आ रहा होगा. So if you get this, my dear, now QS is going to be, QS तो आपने कैलकुलेट कर लिया, right? What else we are left with? What else we are left with, my dear? किसके साथ अभी और बाकी है? So we get this one. So my dear, easily I can get Q in. मैं और तो लिख सकता हूँ QS is going to be what, my dear? क्या लिख सकता हूँ मैं? That I can write mass flow rate, that is mass CP multiplied by T3 minus 533, right? So it is going to be M total CPG T3 minus T2. So T2 we have already find out. कितना है बच्चा? T2 we can find out is given क्या? No, it's not 533. 260 given and leaves at what, my dear? 260 given, right? That means 260 plus 273, that is 260 plus 273. It is going to be, my dear, 533, right now. So I can get, it is what, my dear? 12.8. कितना होगा बच्चा? ये होगा 12.81, 1.093, 12.81, 1.093. Now you have question कि सर कहाँ दिया है? ये दिया हुआ है. Multiplied by T3 minus T2, that is 533. My dear, QS you have already calculated, 8,555. So you can get, my dear, T3, and thus T3 will come around to be कितना आएगा? 1144. T3 आपको मिल गया. Once you get T3, now my dear, I can proceed to calculate T4s या T4 dash, right? So my dear, see, can I write T4 dash divided by what बच्चा? T3. Or you can say, my dear, I can directly write just T4 dash is going to be T3 multiplied by pressure ratio raised to power gamma minus 1 upon gamma. So my dear, you can get T4 dash directly. T3 you have, T3 आपने calculate करा हुआ है. T3 we have already, that is 1144. So my dear, you can get T4 dash, and that will be come around to be बच्चा 685.7. 685.7 Kelvin. You know pressure ratio क्या होगा भाई? P2 by P1, right now. T4 dash divided by, that is 100 by 700, right? It is already given. So now you have T4 dash as well, right? So my dear, if you calculate a T4 as dash, then my dear, I can write efficiency of isentropic efficiency of turbine. That is going to be कितना क्या हो जाएगी बच्चा? It is going to be T3 minus T4 divided by T3 minus T4 dash. See, eta T, it is already given in the question. That is around to be कितना है बच्चा? That is 0.85. So it is 0.85. It is 0.85. My dear, T3 you have already calculated. You have T4 dash, you will get T4, and T4 will come around to be बच्चा पार्टी कितना आएगा बच्चा? 754.4. It is 754.4 Kelvin. So you got T4 as well. Now you have T4. So T4 calculate करने के बाद you can easily calculate WC. My can WC is going to be what, my dear? CP into T2 minus T1. So that will come around, कितना आएगा WC? This WC will come around to be, कितना आ रहा है बच्चा ये? This WC is come around to be, हाँ जी बच्चा, T2 you know that. CP, remember, here you have to take the specific heat not of air. That is what? 1.093. 533 minus 303 करेंगे. Okay, I'll write. This is going to be multiplied by mass of air. That is 12.6 into 1.093, and that is going to be T2. You have calculated 533, and T1 is going to be 30, that is 303. So WC is going to be, कितना आएगा बच्चा WC? WC is going to be 3168 kilowatt. So my dear, now we'll go for WT. So WT is going to be what, my dear? M total. Right now, mass flow rate, that is total CP divided by, in bracket, it should be what? T3 minus T4, no? Actual lenge, okay? So it is what, my dear? 12.81, CP 1.093. Yes or no? It is what? 1.093, 1144. 1144 minus 754.54. So my dear, it is going to be, कितना आएगा बच्चा ये? WT is going to be कितना आएगा बच्चा? WT 5455. Okay. So my dear, W2 you have, now you can easily calculate the back work ratio. So back work ratio is nothing but, easily calculate, my dear. Now you calculate RBW, and that is nothing but negative work, that is compressor work, divided by positive work. So it is going to be, my dear, you know that WC 3168 5455. So it is going to be कितना बचा? 0.58. So now we can check out the correct option. So backward ratio 0.58, correct. Backward, no. Second law of efficiency that we have to calculate. So we have to another calculate, that is second law of efficiency. So eta thermal, let me calculate. So my dear, first of all, let me calculate eta thermal. So thermal efficiency is going to be what, my dear? WT minus WC divided by heat supplied, right? Heat supplied. So it is going to be, my dear, 0.267. You can just simply put the value, you can get the answer. Right now, my dear, I can calculate the maximum efficiency, and maximum efficiency is nothing but, first of all, I have to calculate Carnot efficiency. So it is 1 minus T1 by T3. So ये कितना जाएगा बच्चा? It is going to be 0.735. It is going to be 0.735. So thermal efficiency is going to be what, my dear? That is 0.267 divided by 0.735. So it is going to be how much, bacha party? 0.36. This is second law of efficiency, right? So my dear, here option will be 0.36, right? This is 1 and 3 is going to be correct. कौन कौन सा option correct होंगे? 1 and 3, right? 1 and 3 is going to be correct. I hope you got it, bacha party. Now I'll go for next. Now I'll go for next, my dear. Okay. We'll go for next. अभी और चलेंगे. So we'll go for next one. Consider a rigid vessel of 0.3 meter cube, which initially contains saturated liquid vapor mixture of water at 150 degrees centigrade. The water is now heated until it reaches the critical state where specific volume becomes VCR is equal to this much, and at 150 degrees centigrade. The specific volume of liquid is VF, and that is equal to 0.001091 meter cube per kg, and that for the gas is what Vg, and that is 0.39248 meter cube per kg. Okay. Now, my dear, the mass of the liquid water in the initial state is 96.10 kg. The volume, that means we have to calculate, that is mass of liquid water at initial state, and the volume of water at initial state, that is and volume and mass, that is what is should be the mass of the water at initial state and what is its volume. So basis on that we can tick, that is a correct option. इसमें से कौन सा correct है that we can tick, right? I hope you got it, बच्चा party. So my dear, now I'll go for next. So चलते हैं आगे. So see here. How we can proceed for this? हाँ जी बच्चा, rigid vessel है, right? Remember it is what rigid vessel. So definitely my dear, VCR, that is critical volume, is given. Critical volume given है. So you can easily calculate mass, right? Mass you can easily calculate now. So see my dear, मैं आपको बता दूं, you have given with VCR. VCR is this much and total volume 0.3. So definitely my dear क्या निकल जाएगा, mass. So mass will be what my dear, V upon VCR. So यहाँ से मुझे मिल जाएगा, that is 0.3 divided by VCR, that is going to be 0.001091. 0.001091. I hope everybody got it कि ये कैसे निकाला हूं मैंने. Yes, बच्चा पाती, we have already done this kind of numerical in the pure substance topic, if you remember, right now. हाँ जी बच्चा. Okay, so 0.3 divided by 0.001091. So my dear यहाँ पे कितना आ जाएगा, कितना आएगा बच्चा पार्टी? So it is going to be, कितना आ रहा है, 96.60 kg. It is 96.60 kg mass. Okay, my dear, x1 is going to be V1 minus Vf. V1 minus Vf upon Vfg, right? So dryness fraction is going to be V1, that we have already, कितना है बच्चा वो, 0.003106. 0.003106. Vf1 we have already, that is 0.001091, right? 001091. Okay, and x2 will be what my dear, 0.39248. 0.001091. Okay, Vg again 0.001091. Okay, Vg minus Vf. So my dear, I can get the quality of steam, and that will be come around to be bacha party 0.005149. 15 point, let me calculate, 5149, sorry, 5149, not 15. Okay, so we have x1. x1 मिल गया my dear. x1 is nothing but what, quality of water we have calculated. So it is nothing but, it represents the quality of water. It represents what my dear, quality of water. So quality of water, that means I can define in terms of what my dear, mv upon ml. अरे हाँ या ना, right now, of course it should be. And my dear, mv plus ml, you know that mv plus ml is going to be total mass. Mass of vapor plus mass of liquid is going to represent what, total mass na. And जो quality होगा, that is quality of water will be what my dear, mass of water vapor to the mass of liquid ratio होगा. As we have seen, it is the same, it is analogous to that of what my dear, the quality of steam that we have seen, that is dryness fraction, right? So ml क्या हो जाएगा बच्चा, ml will be what, हाँ जी, ml will be what my dear, can I write from 1 and 2, ये जो दो इक्वेशन है, from 1 and then from 2, can I write like this, ml is equal to m total divided by 1 plus x. Yes or no? I can easily write, yes my dear, I can easily write mv को replace करा by xml. Okay, I hope you got it, my dear. So we got this one. Now, my dear, we'll go ahead. आगे चलते हैं. And my dear, see, V initial, that is V initial is going to be what? V initial is going to be MF into VF. So MF we have already. कितना है बच्चा? That is how much? That is going to be कितना है? It is 96.10. And it is going to be 0.001091. So it is going to be कितना आएगा बच्चा ये? It is going to be 0.105 meter cube. कितना? 0.105 meter cube. It is going to be V initial. Right? I hope you got it. I hope you got it, my dear. I hope you got it. Okay. So 0.105 meter cube. It is a V initial. Right now. So I hope you got it, my dear. So definitely. Now which option is going to be correct? So let's see. अब कौन से ऑप्शन करेक्ट होंगे, that will check. So mass of the liquid water in the initial state 96.10 kg, that we have already calculated, it's correct. The volume of the flow rate, the volume of the water at the initial state is 0.105, that we have recently calculated 0.105. So definitely my dear, it is also correct. So definitely 1 and 2 is going to be correct. Right, my dear? Yes. So here we go for the next. एक और लेते हैं. Okay. Here we took the another one. Just check it out. In an air standard Otto cycle, the maximum temperature 3000 Kelvin and minimum temperature is 300 Kelvin. If the stroke volume is 500 liters and mass of fuel is what? 1 kg. It is talking about the IC engine. Okay. Then for maximum work output के लिए, okay, maximum work output will be, my dear, the temperature after compression is 1000 Kelvin, efficiency this much, clearance volume this much. Okay. So we have to calculate too many facts, right? So my dear, we are going to calculate one by one. एक एक करके calculate करेंगे सबको, ठीक है? So listen to me. देखें ध्यान से. We'll draw the Otto cycle first. We'll draw the Otto cycle. So my dear, let me draw the diagram. मैं यहाँ पे TS diagram draw करता हूँ. I will draw the TS diagram. Or I can also draw the PV diagram as well. दोनों diagram draw कर देता हूँ so that you have a better clarity कि हाँ यहाँ पे क्या चीजें हो रही हैं. Okay. One, two, three, four, right? अभी we can draw that is PV diagram as well. So बच्चा पार्टी PV diagram draw करते हैं and see my dear. PV diagram. Okay. Listen to me very carefully. ध्यान से देखना बच्चा पार्टी. 1, 2, 3, 4, each and everything is clear now. I hope everybody is clear. For maximum work, what is condition, my dear? For maximum work, what is condition? We have already seen that is T2 should be equal to T4. T2 किसके बराबर होना चाहिए? T4 के बराबर होना चाहिए. Right? It is about condition for the maximum work done. Right? So बच्चा पार्टी, if it is a condition, then how we can calculate one by one. So my dear, see, देखेंगे ध्यान से. That means, right? So can I say like this, that is T2 by T1 is equal to T3 by T4? Yes or no? T2 by T1 wait a minute, can I say that T2 by T1 is going to be equal with T3 by T4, right? Of course it should be. So my dear, T2 that we have already calculated, हमने T2 calculate करा था, that is what my dear, under root of what, T1 T3, that is T2 is equal to T4 आया रहा था हमारा, if you remember that formula is right now. So bacha party, if you get T2 is equal to this, but my dear, T2 is also equal to P2 by P1 raised to power gamma minus 1, right? Are हाँ या ना? Of course my dear. So see, T2 we get, T2 कितना आ जाएगा बच्चा? That is going to be 300 into 3000, right? And it is going to be my dear 948 point, कितना आ रहा है बच्चा पार्टी? 948.68 Kelvin. It is given 300 and 3000, right? I got T2. So T2 आ गया मेरा. If you got T2, my dear, you can easily write that is T2 by T1 is going to be V1 by V2. That is T2 by T1 is going to be what, my dear? Raised to power gamma minus 1. And it is nothing but what, my dear? Compression ratio. Right? So I can get compression ratio from here. So my dear, ये कितना आ जाएगा मेरा? 17.78. If you got compression ratio, you can easily get efficiency. But before that, let me calculate VC. So my dear, VC is going to be, VC क्या हो जाएगा बच्चा? 0.5 divided by 17.78 minus 1. Just wait a minute. So what is 0.5? 0.5, you can check it, 5 stroke volume, VS. मीटर क्यूब में कर लिया इसको, मीटर क्यूब में 10 to power minus 3 से मल्टीप्लाई कर दिया, that will get 0.5. इसको 10 to power minus 3 से मल्टीप्लाई कराया to convert it into meter cube, right? I hope you got it बच्चा पार्टी. Now listen to me very carefully. अगर ये क्लियर हो गया VC, so my dear, you get VC and VC will come around, कितना आएगा VC? 0.029 मीटर क्यूब. 0.029 मीटर क्यूब, right? Now my dear, for mean effective pressure PMEP calculate करना है. So how we can do it? Just see. So mean effective pressure is going to be equal to किसके बराबर होगा बच्चा ये? That is 1.718. That is 1. That is M. 0.718 multiplied by temperature difference. That is, and temperature difference will be 300 plus 3000 minus 2. 300 plus 3000 minus 2 into bracket में, that is what my dear, 948.68. 948.68. I hope you got it. So my dear, अब क्या हो जाएगा? Divided by, it is what, maximum pressure, and that is what, my dear, we are getting over here, that is 20.14 bar. It is a what? Maximum pressure, 20.14 bar, right? And it is divided by 0.5. So it is going to be 20, sorry. It is what, my dear? It is going to be 20.14 bar. It is PM, that is maximum pressure. Now my dear, if I go for efficiency, मैं आप क्या कैलकुलेट कर लूंगा? Efficiency from here. So my dear, efficiency will be 1 minus 1 upon compression ratio raised to power gamma minus 1. So it is 1 minus 1 upon 17.78 raised to power 0.4. 1.4 minus 1, that is 0.4. I'm going to get efficiency, and that will be come around बच्चा पार्टी कितना? 68.37. 68.37, right? Right now? Yes or no? Or my dear, or you can do one more thing as well. That okay, we'll do one thing. In another way, we can do that. You know that R is what, my dear? R is, that is, you know that T1 by T2, right? T2 by T1. T2 by T1 is nothing but what, my dear? R raised to power gamma minus 1. So it is 1 by R. So definitely it is going to be T1 by T2. So ये क्या हो जाएगा? 1 minus what, my dear? 1 minus what? 300 by 948.48. Just wait. कितना है बच्चा? It is 948.68. Okay, so you can get the answer, and that answer will come around to be 68.37. 68.37%. I hope you got it, this eta. So here we are done with the eta as well, right? Now my dear, we are going to check that which option is going to be correct. कौन सा option correct होगा, that we have to check my dear. So see, so 68.37 efficiency of auto cycle correct है. Clearance volume is 0.029. I have to check once again. VC 0.029. It's also correct. Mean effective pressure 10.07 bar. No, it's incorrect. That is 20 आया है. Mean effective pressure, right? Right now. So my dear, we are going to see another numerical. एक और ले लें? Yes, बच्चा party, please be fast. Let me know. Can we took the another one, or shall we stop over here? एक और ले लेते हैं. Can we took the another one? Okay. So my dear, see here. One numerical will took one more, and then we'll take a leave. ठीक है? See here. A constant volume gas thermometer is designed, and it shows a reading of 30 mm. Okay, at ice point and 300 mm at boiling point. It is marked as 10 degree Y at 30 mm and 150 degree Y at 300 mm. The thermometer is placed in a tank in which 1 kg of water at 10 degree centigrade and 2 kg of water is 40 degree centigrade is mixed. Then temperature regarding thermometer in, okay, try to find out temperature reading for Y scale, right? So my dear, see again, इसको करते हैं. It is based on the temperature measurement, right? So see, I'll took ice point कितने पे है? 0 degree centigrade, P is equal to 30 mm, right? So let me write at 0 degree centigrade ice point पे, right now ice point पे कितना है बच्चा? Ice point पे 0 degree centigrade, that is P is equal to how much? Ice point ना, it is what? Ice point, and I have P is equal to what my dear? 30 mm, right now 30 में boiling point 100 degree centigrade, P कितना है? And 100 degree centigrade, that is what my dear? BP, boiling point, and I have P is equal to 300 mm. You can check it out. Yes my dear, 300 mm है. Ice point पे 30 mm and 300 mm at boiling point, that is 100 degree centigrade, right? Okay, I hope you got it. So my dear, now listen to me very carefully. जब मैं ice point पे equation लगा रहा हूँ, when I'm taking this at ice point, when I apply equation, so definitely temperature क्या होगा? 0, right now? Yes or no? Of course it should be. My dear, but before that I want to tell you, general equation जो होगी, that general equation will be like this. T is equal to, linear equation होगी AP plus B. So definitely when it is at ice point, so it is 0. A is there, right now? A is there. Yes or no, बच्चा party? Right now A is there. So definitely P कितना है वहाँ पे? 30. So it is what? 30A plus B. B is what my dear? B will be as it is. B क्या होगा? As it is होगा. Yes. So B will be as it is. Another equation I have, that is what my dear? 100 is equal to B, that is A, that is what my dear? 300A plus B. Am I right? Yes or no, bacha party? This equation we get. So from these two equations we can get a value of A and B. So my dear, A is going to be, A का value क्या आ जाएगा बच्चा? A value is going to be 10 by 27 and B का value क्या आ जाएगा? minus 100 by 9. You can calculate. मैंने ऑलरेडी कैलकुलेट करके रखी हुई हैं, सो डायरेक्टली आई हैव रिटन, मैंने डायरेक्टली लिख दिया. ठीक है, आई होप ये समझ में आ गया होगा चीज. ओके, सो माय डियर, अगर ये चीज समझ में आ गई आपको, दैट इज A is equal to 10 by 27 and B is equal to minus 100 by 9, राइट? सो अब ये चीजें आपको समझ में आ गई. नाउ माय डियर, वी कैन कैलकुलेट कि जो 30 mm का जो है, 30 mm करस्पॉन्ड टू 15 डिग्री Y and 300 mm करस्पॉन्ड टू 150 Y, राइट? दैट मींस 1 mm राइज. क्या बोल रहे हैं यहाँ पे? दैट इज 30 mm corresponds to how much temperature in Y degree, that is Y scale, that is 15 15y, 15 degree y. And my dear, 300 mm कितना correspond करता है, कितना equal है? That is going to equal with what, my dear? 150y. अरे हाँ है ना, यही बोल रहा है. Yes or no? Yes, my dear. So definitely 1 mm rise will be what, my dear? 1 mm rise कितना हो गया? 1 mm rise is going to equal with कितने बराबर होगा? 0.5y. 0.5y के बराबर. I hope you got it, my dear. If you get this point, my dear, now we'll find out for the mixture. So mixture definitely एक final temperature पे आएगा, right now? Yes or no? Yes, my dear. So definitely what I'll do, 1 into degree Celsius scale, that is m Cp, delta D लेना पड़ेगा, that is heat is going to be lost, right? So मान लेते हैं final temperature होगा हमारा Tf. So my dear, Tf minus 10 is equal to, right, it is going to be what, my dear? 2 into C. 2 into C in bracket 40 minus Tf. So definitely, my dear, I'll get Tf. So wait. So Tf is going to be what, my dear? Tf कितना होगा? 30 degree Celsius. Tf is going to be 30 degree Celsius. Now, my dear, listen to me again. मेरे पास तो आ गया, that is final temperature is going to be Tf. So again, I'll apply this equation, that is Tf 30. Wait, 30. A का value, that is 10 by 27, right? Yes or no, bacha party? Yes. P, it is P minus 100 by 9, right? B, right? This is the final equation. From here, my dear, I'll get P का value. So P का value क्या जाएगा बच्चा? 111 mm. Very easy. You got P value, right? So my dear, so there is a rise of 81 mm. Rise कितना चल गया? पहले कितना था? 30 का. पहले कितना था? 30 का. But here it is what, my dear? 111. 111 means what? Difference of 81. So rise कितने से कर गया? So rise by 81 only. Rise by, that means 111 minus 30. That is what? 81. Right? Yes or no? 81. 81 means what? Y degree में कितना होगा? In Y scale, 81 multiplied by 0.5. That means what, my dear? 40.5 Y degree हो गया? Yes or no? Of course it should be. And the temperature reading in thermometer क्या आ जाएगा? 15 तो पहले ही रीड कर रहा था. 15 तो रीडिंग इन टेम्परेचर क्या हो जाएगा? रीडिंग इन थर्मोमीटर क्या हो जाएगा, माय डियर? रीडिंग इन थर्मोमीटर जो ऑलरेडी 15 था, ऑलरेडी क्या था? 15 था ना, right? So my dear, reading in thermometer will be 15 plus 40.5. So that is going to be 55.5 Y degree. Yes, बच्चा पार्टी? Yes, of course it should be. So now, my dear, for scaling, scale देख लेते हैं. So scaling, what, my dear? What it should be? Y minus what it should be? ये हो जाएगा 15. Y minus 15 divided by 150 minus 15, and that is going to be correspond to the degree centigrade scale, right? So it is what? 50 minus 32. Sorry, Fahrenheit scale. 50 minus 32 minus 212 minus how much, bacha? 32. Fahrenheit scale. 32. So my dear, you will get Y is equal to how much? 28.5 degree of Y. Right? So now we'll check कौन सा option correct है, कौन सा नहीं है. So temperature reading on the thermometer will be this one. Correct है. Correspond to reading of 28.5 Y. It is also correct. That is 2 and 3 is going to be correct. So guys, this is from my side. So today we'll stop over here because almost it is now 2 hours. 2 घंटे हो चुके हैं. So what we'll do? We'll do the next session. We'll do the next session tomorrow. Right? And one more thing that I want to tell you, daily at 3 p.m. And we are going to continue daily at 3 p.m. Today is what at 1, but daily हमारा कब होता है क्लास? 3 p.m. पे या 1 p.m. पे क्लास होता है. So guys, you can attend, and if you have any kind of a query, you can just contact me on the dhiraj.dvedi@testbook.com. Okay, you can ping me over there. Okay, so bacha party, this is from my side. If you have any kind of a query, you can ask me, or my dear, else we can say tata goodbye. Okay, so bacha party here we stop, and I'm going to take a leave from you guys. So we'll see you in the next class. So guys, take care. Bye bye. Shabba khair. One more thing that I want to add: please stay at home, stay safe, stay online with the testbook.com. Jai Hind, Jai Mama.